Welcome back. In this video, we're going to try to find this limit here of the arccosine of 1 minus x squared over 1 plus x squared as x goes to plus infinity. Here, this function is the composite of two functions, the arccosine of x and 1 minus x squared over 1 plus x squared. A quick way to find in this limit is that the arccosine is continuous and this limit exists. Okay, why? Because we know that the limit of 1 minus x squared over 1 plus x squared is minus 1. Okay, so here we can treat this one as negligible here, and we have minus x squared over x squared, which is minus 1. Okay, and therefore we can write this one in a different manner. So here, taking we are using a limit that we know. If this one is continuous and this limit exists, we can enter the limit inside. So here we have the arccosine of the limit of 1 minus x squared over 1 plus x squared. Here, this is just arccosine of minus 1. And what's the arccosine of minus 1? We can, if we don't know, we can regraph our function. The arccosine is defined on minus 1, 1, and it has values between 0 and pi. So this value here is 0, and this is pi. So the arccosine of minus 1 is pi. This is pi. Okay? And therefore, here, this is just pi. So we can say that our limit here is pi. Okay? One thing that we didn't check is that the domain of definition of this function here. Okay, so here we need to have so this function in the inside 1 minus x squared over 1 plus x squared is defined everywhere because it's the ratio of two binomials, and this is never 0. Okay, but to define this one, we need to have 1 minus x squared, 1 plus x squared has to be between minus 1 and 1. Okay, so therefore we need to solve, to find the domain, we need to solve this one here. Okay, and there are many ways to find the values of x that would satisfy that this quantity is between minus 1 and 1. A quick way is here we can add x squared and subtract x squared, and we're gonna get, so here 1 minus x squared between minus 1 and 1. If we add x squared, we're going to have 1 minus 2x squared over 1 plus x squared between 1 and minus 1. Okay, so here, to get rid of this one, we're going to add minus 1 to both sides. So we have minus 2 between minus 2x squared and 1 plus x squared less than 0. Okay, this is another way. We can rewrite this one in another way by dividing by minus 2. So we have 1 bigger than x squared over 1 plus x squared bigger than 0. This is true for any value of x. Okay? So this is true. If we are not satisfied, we can keep working. We can multiply by this one. Since it's positive, we have 1 plus x squared bigger than x squared bigger than 0, and therefore we have 1 bigger than 0, and this is true all the time. Therefore, the set of values that would make this one true is all the reals. That means the domain for our function here is R. Okay, so this is R. The domain of this function is R. Okay, why are we looking for the domain to be R? Because we taken this limit here to plus infinity. We're gonna see where we are going. Okay, so that's why we have to check the domain of definition. Okay, there is another way to simplify this function here. Okay, we can write this function as I think 2 arctangent of. I think we can do this one here, arccosine 1 minus x squared over 1 plus x squared. We can write it as the limit of 2 arctangent of x. Okay? And we know that the limit of the arctangent is pi over 2. With these two, we have only pi. So this is one way, but you don't need to worry about this. If you wanna work on this, you can prove that the arc cosine of 1 minus x squared over 1 plus x squared is 2 arctangent of x. Okay, it's just some trig identity, and you're gonna see it. Okay, thank you very much. If you see any errors or mistakes, please let me know. The most important thing is that the limit here, and we can enter the limit since this function is continuous and this limit exists. That's the key idea from this video. Thank you very much.